Hey everyone, welcome to my second learning object where I will be describing the difference between beats and frequencies. So we'll notice, if you've seen my first learning object, that sound waves make a return in the way that sound waves cause vibrations through their medium. These vibrations are what we can hear. So frequency can be described as the rate at which a vibration occurs that constitutes a wave. In our case, sound waves. So we hear by having sound waves enter our ear and vibrate our eardrum. So these vibrations are quite important, and the rate at which these vibrations occur are also important. So we can hear different tones or pitches when we have different waves with drastically different frequencies. An example can be shown in this PhET simulation. As I enable the audio, we can hear a frequency at 500 Hertz. When I change the slider, you can hear a different tone. So that's pretty basic stuff. We've all heard that in songs before, or just in everyday speech. But what we don't usually pay attention to is when we have two waves with similar frequencies. When these waves coexist in the same place, they interfere with each other. And these interferences cause a modulation of amplitude. Now this is what we hear as a beat. To show this mathematically, and getting the equations from our textbook, we see that the total superposition, displayed as S subscript total, is actually a product of two cosine functions, one with omega bar as its argument, which is our mean angular frequency, and the other with the difference, or angular frequency difference, which is delta omega. So the mean angular frequency is actually the frequency at which we hear the new wave, or the product of the superposition, whereas the angular frequency difference is the rate at which the new wave modulates, or the modulation of its amplitude, which we can hear as the beat. To show this graphically, we see here with these red curves the actual angular frequency, our mean angular frequency, and in the blue we see the angular frequency difference. So we can see the blue has a much lower frequency than the red, and this arises because the original waves are so close together that the difference between them is very small, or difference between them is very large, and the angular frequency difference is large as well. That wraps up my learning object, and on this slide we just have the references to the simulation, the equations, and that picture. Thank you for watching.